Hi everyone, welcome to ST Skills. This is our weekly system design series. One week, the current plan is like 1 week we deep dive into one of the system design topics or like any concept. Another week we'll have mock interview. This week we have Abhishek volunteering to present on deep dive on one of the fundamental topics. It's data encoding and if any of you are new to the ST skills, please join our Discord channel and look for announcements to see which all other sessions are going on, and yeah, feel free to join them. And so I will yeah, if you are interested to present any of the future sessions also, please bring me. And with this I'll give the forum to Abhishek. Yeah, please take over, Abhishek.
Yeah, thanks a lot, Naga, for the introduction. Hey, everyone. I'm Abhishek. Is someone saying something? I think. Okay.
Yeah, Abhishek, I was saying something.
Yeah.
Actually, I'm new in this group, and I want to know how can I catch the flow.
Okay, so yeah, you don't need. I'll start from very basics. Don't worry about it. And if you have any questions, just interrupt me. But you don't need to know any flow beforehand. Like I'll start from the beginning, so don't worry about it. Yeah. So basically, like I'll share my experiences of how I have used data encoding, why we need data encoding and stuff like that. And please free to interrupt me. And also let's have it as a discussion, and whoever has their experiences, feel free to share their experiences. So yeah, so basically like a very basic question, which I think Asim always focus on, and which is a very good question to start things is, why do we need encoding, right? What is the use of encoding? So to start with, I'll take a very simple system design problem. I'll just draw a rough design, and then we will see that do we actually need encoding, or if we don't need encoding, then why should we spend time on it, right? So let's say we are building some portal for ST skills where new users can sign up, and then we can add the presenters to that portal, and the users can view what are the future sessions we have, right? So let's say we have to build a simple system like that. I'm not going to go into the details of requirements and all those things, but I'm just drawing a very rough architecture. So a client will have an API where he can, add himself as a user, and we will have our multiple application servers, which will be taking these requests, right? And probably, let's say I want to build a microservice kind of architecture. So I have some other microservices inside my overall service design, where like here I have some validation service as one microservice, which is used to validate the data. Let's say I have another microservice, which is a logging service, which I call to log some data. And then I have like some disk as a service, disk storage as a service where I store the data, right? So basically, when the client requests come, I will do some processing in the application server. Probably I'll make a call to this validation service. Probably I'll make a call to this logging service. And finally, I will store the data in my DB, right? So in this kind of architecture, like in most of our design discussions, we always talk about these boxes, right? That what happens in this boxes, what happened in this, what is this box doing? The thing we always miss out is what is happening behind these arrows. What exactly is the data we are sending in these arrows? And in some cases, if we have to store the data in those files, how are we actually storing the data in those files? So basically, this is where data encoding comes in. So whatever data you have in your code, in your applications servers. So that is the representation of the data in your code. But when you are sending that data over the network, or when you are storing that data in those files, then it needs to be represented in a way that could be understandable by those networks and this. So we bring down the data to its very basic structure in the form of bytes, and that's how we transfer the data and store the data, right? Uh, is everything fine up till here? Any question?
Yes, Abhishek, yes.
Cool.
Yeah,
Okay.
Abhishek, sorry
Yeah.
to interrupt, but I
Yeah.
have some questions. Yeah, I have heard about the encoding and hashing as well as encrypting. So what is the difference between these three?
Yes, encoding hashing. Probably maybe take this question at the later stage when we know what encoding is, and then we can actually see like how will it differ from encrypting and hashing. Is that fine?
Yeah, sure. No problem.
Okay, cool. So okay. So now, like, I want to ask some questions from the audience, and let's see how it goes. But basically, so like, let's zoom into my application server. In my application server, I have some code, right? And in that code, so what I'm doing is I'm creating an object of type SDE, right? SD is my object. I have his name. I have, let's say, some ID. I have his skills. What are his skills, right? And I have this object. Oh, sorry, I have to scroll it here. So actually, I'm writing on my laptop and screen sharing here. So let me know if I have to scroll. Okay. So yeah. And I have SD skills, and now this is like my object in my code, right? And now I have to transfer this object, right? So like, what are the problems? Why do they say that I have to encode this data? Why can't I send these my application objects directly over the network? Any thoughts?
I believe one could be size. Probably size can be reduced by encoding, and one could be, is it like some kind of a, I don't know, I was thinking probably we should have a contract for sending and contract for receiving and understanding.
Okay, yeah. So these are very good points. So like
yeah, I would also like to add. So basically, this would be an object in some language, right? Say Java, C# or anything.
Yeah.
Now, when you want to send it over the network doesn't know about the object. Network understands 0 and 1, right?
Exactly.
So a stream of bytes. So we can't just transfer an object. I mean, it has to be like a stream of bytes, a stream of data that we would be transferring. That's why you need the encoding and decoding, essentially.
Exactly, yeah. So great, yeah. So both of you have covered three very important points. So yeah, I mean, this object is like a representation of data in that particular language, and that particular language is operating on the data and using my memory and my data address in my memory, pointers and all those stuff, right? All that knowledge of my hardware, my memory, network does not know that knowledge. Any other system, any other program does not know that knowledge. So if I transfer it as it is, like, it will be meaningless. It won't have that information. So I have to encode this data in such a way in those bytes that everyone can understand this standard notion of my data, right? So this is what the third point was, right? The other thing is one other thing is contract. So basically, and it depends, like, contract we might want a contract or we might not want a contract. So basically we are talking about here a schema that when we are, so I have a sender and I have a receiver, and they both, sender wants to send some data to receiver. So is there any contract? In some situation, we would want a contract. We would want sender to send only data with a particular contract. In that case, we will define a contract. But it also depends that in some situations, I don't want any contract. I want a schema-less data. So it could be a schema-less data. So contract, like, it's not a definite way to say that we have to encode the data. The third thing is size, right? So size is also important thing. So when I'm sending this object and when I'm sending this in network, it is consuming my network bandwidth. So I have to make my best effort to send this data in the most compressed way, right? So now looking at these three important points, I think it's important to encode the data. And so now I will slowly start moving into what are the techniques of encoding data. Okay.
Quick question.
Yeah.
Sorry, were we supposed to raise hands or something? I'm sorry.
No, it's fine because I'm not watching it, anything like that.
Okay,
Yeah.
okay. So a quick question, like we are calling this converting this object into bytes as encoding, but isn't this like serialization? Like we are serializing it into a stream of bytes, the object, and the server.
Yeah, I think they are like.
It's the same terminology. It's the same terminology actually. Encoding, indirectly means serialization.
Yeah.
Okay.
But wouldn't that serialize, like, in Java, you have object, you serialize it and send it to the other side. The other side need to have the same class to deserialize it, to make it become Java object again.
Yeah, correct. If you are serializing using Java, you have to deserialize using Java only. But like techniques that he is going to present today is generic, irrespective of the language. Like if you take the Java serializable, you have to depend on another receiver using the same Java language to decode.
Yeah.
But if you use some of the common techniques which Abhishek is going to present, it's it's language independent.
And so the point is, I'm not present. Like my focus is not on any one particular topic. So these are very good points in the discussion. That So why can't? So we said that we have an object in a language. So why can't we give this task to the language that, hey, language, you know what those memory references are, how data is stored. You just encode the data for me, and at the receiver end also, I'm going to use same language, and then the same language can decode the data. So this is actually one way to serialize and encode data. There is no problem about it. If that requirement fits you, you can actually use that java.serializable. It will encode the data, and on the receiver end, the receiver can deserialize it, right?
Question. Question. So when the data is, when you're encoding this data, isn't the encoded information, which encoding and psi or so, it's going along with the data? So instead of the receiver trying to understand, he should also, isn't he also receiving the information with what encoding this data has been sent?
Yeah, I mean, it depends. So the receiver should know that, you are saying that the receiver should know that it is Java encoded data, right? Is that what you're saying? And you should interpret it as being encoded by a Java library.
No, sorry. My example, what I'm trying to say here, instead of, let's not say sender receiver. Let's say that you're storing the data in a file, notepad. You're storing file. Everything is encoded in some certain format. So that information with what type of encoding has been applied to this data, it's already part of the data. Maybe you can think of the first metadata of a file, or the metadata about this data already contain this, what type of encoding is applied to it, instead of the receiver trying to make sure it's what type of encoding. It's Java encoding, that encoding, this encoding. That information also goes along with it, isn't it?
Not always, right? That's not necessary. Yeah, like even if you store it via Notepad, the other person has to know where the metadata is stored. Same with an HTTP call, right? You have to know where the metadata is.
Yeah,
Like
I mean, yeah. Otherwise, you are saying the receiver will iterate over all possible encoding techniques, and it will, I don't know, or yeah,
That should
like
not be the
receive.
case, that it has to iterate over all the encoding. So what I'm saying, in a regular way, so there are two aspects to it, that you store like a file, or you send it over protocol, HTTP or HTTPS or so. When you're sending something over protocol, I believe your point does make sense, because it's you who's choosing to encode, and then it actually goes as a part of a body, while post call or so. And you can have metadata as a part of the request itself as a separate variable, what kind of encoding that you are doing, instead of a receiver, trying to iterate over what it actually is.
Yeah, I agree this to some extent. Like if we are doing like storing as a file in the same system, there is no network, right? Like basically, mostly take an example of the file extension that could indicate like what kind of format it is. So yeah, so if it is likely part of the same system, I mean, like it's most of the times it's embedded within the file itself, what encoding it is. And yeah, since I think Abhishek intention to present today was mostly to cover the network scenarios, because yeah, if you go to the distributed systems, like where you have like millions or billions of documents, or like requests being sent over the network, so there all of this the encoding what you are using definitely is important to be, yeah, in many of the scaling decisions.
Yeah, and just to add to it, like I think it depends if the sender or receiver know how they're going to communicate, then they can decide that what the encoding technique is, and they probably don't need to send it every time, that encoding technique. But if there is some external service and that does not know about my system, then I would need to send it that encoding technique, that hey, my data is encoded in this way, and you should deserialize it using whatever technique I have used for encoding.
Yeah, thanks, Abhishek. One more question I have is, my understanding was earlier on that, that when we encode into NSI and all that, right, or any standard coding, this is done within the box. I mean, before sending it over to, instead of trying to interact with some other box, which is application server or logging it somewhere. So what is that use case where, you want to light up a separate application servers, which can do the encoding for you, and then write it down, or the logs, or the diagram that you presented earlier on. So I'm just trying to understand what is the use case of having separate servers which can encode for you.
No. Okay. So yeah, probably we are jumping a little bit ahead, but so my point here was that these application servers and their responsibility is not just to encode the data. I'm saying that in any system design, just forget about encoding here. I'm just saying in a system design where, can someone mute?
Yeah.
Yeah. So this application service has to communicate with the validation service, right? It will send the data to the validation service, which will validate. So I'm just saying that it needs to send this data over network. How will it send that data? Similarly, if there is a separate logging service, it needs to send this data to logging service. So how is it going to send the data? So to send this data over the network, every time they are sending, they have to encode it and then send the data over the network. Otherwise, the network won't understand that what is the object representation in the code means actually over the other side.
Thank you for clarifying. I think I got confused with the diagram, or their objective in terms of data encoding. Thanks for clarifying. I think I got it. What you're trying to say.
Yeah,
I have
let's
a
continue,
question.
Hitesh.
I have one question.
And so Naga, just to interrupt everyone, sorry. So I'm not keeping track of time. Please, you moderate, Naga, that if you think that we are spending too much time on some particular topic, please let me know and we can move ahead. Okay. Yeah. So someone had a question.
Yes. So my question is that it might be Java specific, but you said that Java serializers work this way that let's say an endpoint is sending serialized data over the network and another endpoint is catching that. So how does deserialization actually take place? I mean, how does uh, whatever, let's say that I intercept that data and I'm not that part of the contract, let's say. I'm not that Java application that should have intercepted that data. So will I be able to decode that, or how does deserialization take place in case of
Yeah.
Yeah, I think let's take that question like after he walked through some examples. Is that okay, Asif?
Sure.
And just to answer it, I don't know exactly how that happens, but like this is some abstraction for me that the language will take care of encoding and decoding it. So I don't know that if we don't have a contract, like if someone else is interpreting, can they decode the data? Can they not decode the data? I don't have a good clarity on that.
But Java has a service called JNDI that can take care of these things.
JNDI. Okay.
Okay, right. So just moving a little bit ahead. So the problem which I have read with these language-specific serializations is, first thing is that these are language-specific, right? So if later, if we want to change the language of our system, or because the aim of these microservices is that every component is independent. So I think in some way we have taken that independence away because we now cannot change the language of the system. So we have made a system language specific. Second is these serialization and deserialization, in-memory deserialization, they are expensive. They are not as fast. And I don't have a number, but this is what I have read. So these are expensive to do. And also they are not very good at backward and forward compatibility. We will discuss what backward and forward compatibility is, but these language serializations have not completely thought of it, and they're not good at this backward and forward compatibility. So we need. Then there are some other ways to encode data, and I think everyone have heard of this JSON XML CSV, right? I don't know why. Okay.
Yeah, actually
So now another so this is another technique to serialize our data that we are using JSON XML. So what we will do is we will use a JSON library, and whatever data we had above here, it will serialize it into the form of a string, a JSON string, and JSON string, a string could be easily converted to bytes, right? And then we can send that data over the network. So this is one way. So my JSON will look something like this: name, ID, let's say 23, scales.
Abhishek, I have a question here. Whether it's a JSON serialization, XML serialization, or whatever it is, I mean, so when we say an object has a variable name, and the data or the value of object is stored somewhere else. A serialization is what you are describing here, a JSON serialization. And encoding is something different that will come later on. I mean, when you say the variable name, I mean, is it that every character in that serialized format and some /n also in the end, how they will be represented, what the value of every byte will be? I believe that comes afterward, right?
So, I mean, so actually,
if you take JSON as the example, this is the format, I mean, like of the data, right? Like there's no further translation. I mean, like suppose like this, how JSON serialization works. So you just convert JSON object into a string, JSON string, which is
Yeah.
again human readable, and then
Correct.
you convert to UTF-8 format, which is standard, and all machines have libraries to convert to UTF-8, and because it's a Unicode style, right? So you convert to UTF-8 bytes, and then like transfer over the network.
Then
Or like store it as a file.
Yeah, you store it as a file, but when the things goes, whether it's a JSON, it's a plain text, it's an XML, or it's a CSV, everything is like, there are a lot of characters in it.
Yes,
right?
yes.
You know, when you say JSON, it's a contract, it's JSON contract. When you say XML, it's an XML type of contract, or it's a
Yes,
CSV
yes.
comma
Yes,
separated,
yes.
right?
Yes, yes.
All are just data.
Yes, correct.
So
when an encoding happen and psycho encoding or something else happen, it happens on the data, on the bytes, which is not actually. I'm trying to understand the
wait.
message.
So just quickly, let me go over through this. So one thing is this software engineering, lot of terms are overloaded. But here, like what I mean to say is, now we have encoded our object, which was my object in the language, into string. Like it's a simple string, and it's very easy to convert this string into bytes, because every character you can represent by 1 byte, right? So for this opening bracket, you will have whatever is the byte representation, then whatever is the next character. So once you have converted this object to a string, what we are saying is, how we have achieved the encoding is, once we have converted it to the string, it is encoded for us. And now we can go next level, that how this string will be represented in bytes. I can show you, I have so later in this class, where is my Visual Studio? Yeah, so I'll show you, 1 second. So I'll show you that how we are encoding data through JSON, how we are encoding data through Protobuf, how it is serialized. And in bytes form, I'll show everyone that how the data is encoded. So yeah, now you can go ahead.
Yeah, sorry, I was interrupting. You know, what you are showing, is this, will you call this encoding from going
that's what I'm saying. It is in software engineering, lot of terms are overloading. So here, this means encoding. Yeah, this is what I have encoded to. And probably, I don't know what encoding you are referring to, but this is encoding. Encoding does not have to be something very fancy that it is doing. This is encoding. That object is created to a string. So
yeah, this is a simple
encoding.
And what is UTF format that Naga was talking about?
It's just like Unicode. You have the ASCII, right? Like I think it's UTF-8 is a one of the ISO standards of character or like characters representation or bytes representation. So it's just
just basically.
I think when we are converting that JSON back to byte and using the UTF thing, so UTF is basically an encoding standard which we are using here. Right. So conversion from JSON back to bytes is what the encoding which is taking place here, not when we are converting that object to a JSON format.
No, that is decoding. So this is encoding, and this process is encoding. When you convert it back, it is decoding. This process is called decoding. Encoding, also serialization, and this is deserialization.
No, I was talking about conversion of JSON back to byte array, not conversion of byte array back to JSON object. So when we transfer over the network, then it is basically communicated in the form of bytes, right?
Right.
So we have this
that is encoding. Yeah,
and we use this UTF-8 for encoding the data and then publish it back to the network.
Yeah.
Okay. Yeah, guys, let's keep questions. Hold on, like let him cover some concepts. So, and then we will once at least we finish some key concepts, then we can come back to questions if something is not clarified. Okay?
Yeah. Can we let Abhishek finish his presentation? Then we can take the questions maybe in the chat or later.
Yeah. Right. Okay. Cool. So where was I? So in JSON, we have encoded this our object, the memory representation of object. And so now this is basically a string, and that string I can represent in terms of bytes, and those bytes, how I want to represent in bytes, that depends on my encoding technique, whether it is UTF-8 or ASCII. So basically with UTF-8 or ASCII, what we are saying is that for each character, how many bytes we want to take, right? And if we know that our characters, they will only be in the range of 0 to 256, they can be represented by that, then I will need less bytes. If my characters span over multiple languages and I need a wider range, then I will probably need more bytes to store each character. So this is what the encoding, we are talking about another level of encoding, that now we are encoding it in terms of the string in terms of byte. So finally, the string is converted into bytes by any of those encoding UTF-8, ASCII, and then we can send it over the network, right? Okay, let me scroll. Yeah. Okay, so now, yeah. So now we have seen that we can use JSON, we can use, similarly, we can use XML and other things, right? So I just want to highlight that what are the advantages and disadvantages between these. So one thing is XML. Generally, JSON is less verbose than XML. In XML, you have opening and closing bracket for everything. So you are storing a lot more information. And we discussed before that when we are sending some data over the network, we want to store it in as much compact way as we can, right? So JSON is better in that way compared to XML and CSV. The other thing is that JSON, because we are sending the data in terms of this string representation, which is bytes, so it is very easy to read the data. The data is very readable. And also, because we have not defined any, previously we have not defined any contract or any schema, so it is very easy that if we want to change the data, if we want to add more fields, if we want to remove the fields, we don't have to worry about it because we have not defined all those things, right? So these are the advantages that we use the JSON for, and not having a contract, not having a schema is a great help for me, because if the other party, I don't want to share my internal systems, I don't want to share this schema, I can just send him the data that you were looking for this data, here is the data, take the data, read it, and do whatever you want to do, right? So that's why like JSON is used in lot of places. So like coming up in our system design. So when we had our client, and client was sending us the data, right? So client will always send us the data in the form of JSON, because client does not know what is my internal contract, what is my schema. So in the post request, that's why we have seen that when we make these post request, web request, we in the message body, we send the data as JSON, right? Similarly, when the application server is returning some data, that what are the list of sessions, it will return that in JSON format, right? So this is how we have used the JSON. Now, a question comes here that could we, when we are internally talking between our application servers, so basically talking about these messages where I know this is my code, is there a way I can compress the data even better and send the data in even shorter way? So now we are going to move forward and see what are those other techniques which helps me compress data even further. So basically, we have seen this above representation of JSON, that in JSON we are storing string, which is name. So basically, a JSON has to send this entire string of data. But imagine a scenario that this is the sender, this is the receiver. I know that I'm expecting the data in this schema, that first field will be name, second field will be ID, third field will be skill, and receiver also knows this information. We can probably compress the data even better, because now the sender and receiver know exactly what they want. So how could we compress the data? One technique could be that instead of sending this entire name, right, NAME, I can give this an integer ID. So I can give this ID 1. ID could be represented by 2. Skill could be represented by 3. So this each string has an ID, right? And on the receiver end also, because I know the contract, it is my own internal system, I know that this is the ID of these things. So now when I'm sending the data, instead of writing it as name Naga, I can say 1, which represent my first field, and I can send 1 as Naga, then 2 as whatever his ID is. Let's say ID was 1, and then skill is whatever his skills are. So let's say coding, design, right? So now see, now we have reduced the space where we are not sending name, we are not sending I, we are not sending skills. Also in JSON, we were using all those opening brackets, closing brackets. Probably we have space, we have saved some space over here. But no, but actually we don't know that once I have started this 1, I have written this ID 1, I don't know where my data will end, right? Where up till how much time I have to go and see the data for this ID 1. So probably with ID 1, I will also store that what is the length of the data for this ID 1. So probably I will store something like 4. So now on the receiver side, when we have to parse the data, we will say, okay, this 1 represents name, 4 represent length. So now Naga, I have to look up till Naga. Now this 2 represents my second field, right? And so this is like a basic representation that how we can compress the data and send the data. Let's go over to the details of this thing, and let's go over how actually so the idea behind Protobuf is this, that it is compressing the data and sending the data. And let's look at over the details that how it actually does that. So I'll quickly jump into the code and see and show you like what I mean to say when we are internally talking between the applications. So let's say I have these 3 like 2 services. My service 1 was a producer, which takes some input data. Let me write the design of my system, and then probably I'll jump into the code. So what this system is doing is I have a service 1, right? I have a consumer. So this service 1 takes the data and writes it to a file. And then this my consumer, it reads the data and then prints or whatever it wants to do, right? So now this service 1 and this consumer, think of these as microservices within my application. So I like internally, my teams own these microservices. I can define a data contract between these 2 services that they can share and reuse and send data and talk to each other. And here, to make things easier, like I'm storing the data in files and then reading it, but probably on the network, they can be directly talking to each other and sending the data, right? So now looking at so how actually I will make the system is I will make a shared library, which is my data model, which is my data contract. So in data contract, so this is how my data contract will look if I'm representing it in a JSON. That I will say that my data will contain ID, my data will contain name, and my data will contain a list of skills, right? And this data contract, probably I can do it a NuGet package, and then my service and consumer will read this data contract and they can encode or decode the data using this data contract, right? So so now in my service program,
Abhishek, is there a chance you can increase the screen
size? Oh yeah,
yeah,
sorry.
So it's more visible.
Is it clear now?
Yeah, I think it's better.
Okay, cool. Yeah, so I think Hitesh, you were saying something?
Yeah, that's okay. Thank you.
Yeah. Okay. So this is how I have encoded my data, like I have defined my data contract in JSON. Side by side, I'm also going to do the similar thing in Protobuf. So in Protobuf, I will define a message. And again, same thing, that message will have an ID, message will have a name. And so list is a repeated thing, repeated skills. And I have given ID to each thing. So instead of using ID as a string, it will use this ID to represent the data, right? And now let's run the program. So in our program, I have exactly the same data. I will encode the data once using the protobuf, once using the JSON, and then I will write the data to the disk. And then on the disk, we will see that what is the size difference. We will decode the data and actually see how the data was represented in bytes and how it was actually encoded, right? So let's run this project. So I'm storing the data here. So the two output files should come here once the data is encoded.
Hey Abhishek, meanwhile it's running, do you have plans to show how the encoding process works after this, or
Yeah.
later?
Yeah.
Okay. Sound.
So now this system has created two files. One is JSON data, which was encoded using JSON. One other is Protobuf. So just I'll show everyone like this size difference. It's the same data. The JSON has used 53 bytes and Protobuf has used 25 bytes, right? So this is one difference, that the data was the difference in the size. If you look at the data, so in JSON, the data was encoded in the form of strings because Notepad interpreter can easily read strings. So I can easily see what that data was, right? Now let's open how Protobuf has stored the data. See, so now Protobuf has encoded this data in the form of bytes, which are not exactly strings. And at some places it has string because Notepad as a text editor, it knows only how to interpret like string kind of data. So these special characters it cannot recognize, but this is how my data has been serialized by Protobuf. Right. Just before jumping into that, breaking down exactly the data in terms of byte. So I just want to show now what I will do is on the consumer side. Again, I will use this data model, right? Whatever was the data model, I will use the same data contract shared. And then I will read that data from the disk and I will read the protobuf data and I will read the JSON data. So both can read the data and both can output my data however I want to. So if I will set this up and I will run it, I'll let it run and then it will show me the data outputted from both of these things. Okay, so here the output of Protobuf was that I have all my information, name, ID, skills, and similarly from JSON, right? Okay, so now let's exactly see how Protobuf has encoded the data. So I have this hex viewer where I will put both of these files, and so now if we look at this data, so we were talking about, right, how it is being sent across the network in the form of bytes. So basically strings are represented in form of bytes. So this is the binary representation. Each string character is taken.
Abhishek, can you increase the font size again a little bit?
Yeah. I don't know how I can increase.
Is there a possibility to zoom the screen a little bit?
Something like that.
Okay, yeah, I think this is better.
No, but I have to show both the parts. 1 second. Okay. 0, but there is no middle value. 100, 200.
value.
There's a view option there. Can you please use that?
I'm sorry, view.
Or you can just maximize the screen. Just to minimize.
Maximizing won't increase.
Yeah.
So you cannot.
Maybe a screenshot and then zoom, or like.
Oh yeah, that's good.
Won't you able to increase the font size?
Where is the font size? This is not the font size. This is like how many characters you see in one line. Yeah, this is. Sorry about this. I don't know.
View.
Adapt to window with visible code.
Yeah, I think you can. Yeah, that's a simple thing. Maybe you could just take a screenshot and try to zoom, and then maybe we can come back.
Just let me try once more if magnify is a good option. But actually, okay, 1 second. Let me compress this thing. Fire. What the? No, it's not so great. So actually, I want to go over the each character, show it.
Oh yeah, I think this makes.
Okay, let me take the screenshot. Where is the screenshot? What?
Oh, someone says like in Zoom you can increase the screen size. Do you want to try that? Maybe?
No, that is for the viewer. You can always zoom. Like if you can
okay.
two options and you can zoom to
1 second. Let me try quickly one more thing. I think display settings. If I scale and layout things, let's make it more big.
Yeah, I mean, like I think whoever wants it, they can go to view
I think on the viewer side it is there. Like in the view options, you all can.
Okay.
Yeah.
The people.
I think it's okay for you. Yeah, you can go ahead.
Yeah, you go ahead. Because that will show all of your settings.
Yeah. No, that's fine. Okay. So yeah. So each in the JSON form. So I was sending the data with all these characters, opening bracket, right? So opening bracket was represented by 1 byte, which is this byte. Then like this opening codes, ID, and everything is sent like that, right? So basically, how many characters I have in this string, that many. That was the size of my overall byte. So basically, I had 53 characters in my string, and 53 bytes was the size of my data. Right now, this is simple. This is what we understand. Let's look at Protobuf. How Protobuf is sending the data. So Protobuf has very different representation. So if you will look at the byte, so this each representation. So first, so how now? Let me explain how Protobuf is encoding the data exactly, and then we will see how it is over here. So this and this is okay. This is here. This is here. Yeah. Okay. So in Protobuf, how it is actually storing the data is, so it has like first byte, right? In first byte, what it will store is in the last 3 bits, it will store the data type. So whatever is the data type. So for each data type, it has a notation. In these 7 bits, it will, sorry, not 7. 5 bits. In first 5 bits, it will store what was the tag. So I used the tag as 1, 2, 3, right? So it will use these 5 bits to store the tag number. So here I'll open this encoding, how it is done in Protobuf. So if we look at my data, my first thing was this ID, right? And ID was of type string, right? String is represented by 2, right? So that's why if we will look here at the data type, so string will be represented 0, 1, 0, right? And this 5 bits will be represented to store my tag. My tag was 1. So my first byte should be this 0, 0, 0, 1, 0, 1, 0, right? Now if we look at this, so this is the first byte. So first 5 represent my tag and 0, 0, 0 represent my data type. And what was my data type? Oh, data type ID was int, right? Sorry, ID was of integer. So I should not be looking here. I should be looking here. So ID was represented as int, right? And in the Protobuf definition, they have defined that integers are represented by 0, right? Int32 is represented by 0. So that's why you see that it is 001, 000, right? The next string is used to store that character itself, what that character is. So this is storing my data of this string. Then moving on to the next character, again, here, this is storing 12. Wait, so for string, it will store, so this byte is the size of the string, right, which is 4. This byte stores, again, 0010 stores the tag, right? The tag is 2. 010 stores the data type, and data type is string. For string, we saw that we are using 2 as the data type, right? And I exactly don't remember what this is, but yeah, so basically if we go here,
I think this is hexa, or what kind of encoding is this? I think it's in hexadecimal, right? So
okay,
you
so
need to convert those into binary bits, be able to see what each one was.
Okay, is it, oh, so sorry, I think I was not highlighting. So hexadecimal is here. So basically all this data is in the binary format, right? And this is just a way to read the data. Hexadecimal is just a way to read the data, but all this data is here. If you see, look at this place. I will keep scrolling, look at this place. So this is the byte representation of data. If we want to understand how this byte is represented as hexadecimal, then it's very simple. So we have 8 bytes, right? So basically what hexadecimal does is, because hexadecimal is 0 to 15, so hexadecimal value can store 4 bits worth of information, right? So that's why first 4 bits are represented by 1 hex, second 4 bits are represented by second hex. So that's why, so this is just this viewer, this hexaml viewer, to just easily read the data. It has written those bytes information in hex, but basically you should be looking here if you want to see the byte information. So yeah, so this is how the data was encoded using Protobuf, right? And we can see, because we are not sending those exact strings, we have compressed the data here, right?
Abhishek, sorry to interrupt. Can you explain what is this tag you were talking about, the first 5 bits?
Okay, the first 5-bit tags, yeah, okay. So so we discussed that when I want to send my feed, so basically look of it as a key value pairs, right? So my ID is the key and the value is whatever is the value of the key, right? So I'm saying that instead of sending my key as a string, right, ID, I will assign it an integer value, and on the receiver side also I will have that same data schema. So I will know that 1 means ID, right? 2 means name, because I'm using that same data contract. So that's why when I'm defining my data schema, I'm giving each of those string value a tag. So this is called tag in Protobuf. So this is 1, 2, 3 tag. Now when Protobuf is encoding the data, my key is represented by tag. So it will store that tag in the first 5 bits. But another question could be, what if my tag is bigger than 5 bits? Then it will use one more byte to store the tag number. So then basically your tag number will be stored in 2 bytes. That's why if you will read the Protobuf documentation, they say that you should keep the tag numbers low, and the fields which are frequently used, the fields which you are frequently sending over the data, give it a lesser tag number so that it can be stored within that 1 byte, within the 5 bits.
Okay, thanks.
Right? Okay. So yeah. So this is how the Protobuf has encoded the data, right? Okay, now moving to this another topic, which is the problem we will see in the system design and actually when you're implementing your services that are hosted on multiple machines, is backward compatibility and forward compatibility. So I will just show like what exactly backward and forward compatibility is. So let's say I have my application server, right? I have my multiple application servers, right? And so this is the version 1. My application server is hosting version 1 of the code. So, and I'm writing the data somewhere. Let's say here I'm writing the data. So when I have, so initially, let's say I had these 3 fields, name, ID, and skills, right? So, and my application logic was this. So it was storing the data in this format, which I will name as D1, version 1, data format, D1. So now my data is living in this format, D1, right? Now, let's say in the future, I decide that I want to add one more field, which is hobbies, right? And I'm adding this another scheme. So now my data is in this D2 format. So I will mark everything with red. Okay. So I've added another field, hobbies, which is data2 format, right? And now, so I will also make updates in my code that it should also read and parse this hobbies as a data field. So my application server will be running version 2. So now when I update my application, generally we do a rolling deployment, right? That one machine will be updated with the latest version, then slowly I will be updating second machine. So this machine is also updated. So let's say now we are in this state where the 2 machines were updated with this latest code and the 1 machine is still in the previous version of the code, right? So now whatever data this application server 2 will read, it will write in D2 format, right? It will write in D2 format. So now 2 interesting scenarios can happen now. One is application 2 might have to read the data which was written in this previous format, D1 format, right? So this is one scenario. Another scenario is that this application server 1, it might read the data which is in the new format, data2 format. So ideally, we would have want that AS1 should be reading D1, AS application version 2 should be reading D2. But you see here mismatch that in this first case, application server 2 was reading data 1. So this phenomenon is called, I don't know, phenomenon is a right word here, but this is called a backward compatibility. So backward compatibility is my new code. When your new code reads the old data, this is called backward compatibility. forward compatibility is you have this old application server and it is reading the new data, right? So this is forward compatibility, that your older code should know about your future data. So that's why it's forward compatibility, right? So whenever we are designing applications and whenever we are sending the data, we will always be doing the modifications in our schema. So we have to be very careful about not breaking the backward and forward compatibility, because the applications are not updated atomically. They are updated in rolling upgrades one by one, right? So so these data schemas, Protobuf and all, they have to also support this backward and forward compatibility. We have seen in JSON, it's very simpler because JSON is schemaless. So what happens in the JSON is, if it does not find the hobbies list, it will ignore, right? So in applications server 2, in my data 1, I would not have hobbies. So while reading the data, it will not have the hobbies field. So it will fill it with an empty value or null value. So which is good, right? Which is great. Here, my application server 1 did not have hobbies as a field. So when it will read the data 2, it will ignore, because it cannot understand hobbies. So it will just ignore the field, but still it can read the other fields. So which is again fine. We can do with it, because basically my application 1 will be behaving like my service was behaving in the previous way, which is okay, right? So with JSON, it is easier. With these schema defined things where we have protobufs and all, so because you have defined the schema between those two interfaces, so one thing you have to ensure is that you are not adding any required fields in the schema. So basically in Protobuf, when you're defining your schema, you can mark each of the field as required, that this is mandatory or not, or optional, right? By default, everything is optional, but I think you can add the required field for the fields. So what problem can happen is, let's say when I was adding hobbies as a new field, and if I have marked it as a required field, when I append, then it will create a problem, because now when my application server 2 was reading the data from D1 did not have this hobbies as a required field, so it will break, right? Here, my application will break. So that's why an important thing is that you should be careful about defining your data schemas, and in the future you cannot add the required fields. And similarly, if you are removing, let's say there is a scenario that you have to remove, you can never remove a required field, because again it will create a problem, because if you have removed a required field, then what can happen is, so in data 2 you will not have the required field. And so when the application server 1, which was reading this data, it was expecting that required field, it does not exist, so it will break over here, right? So yeah, so this is something about backward and forward compatibility. But otherwise, if you don't have this required field, how Protobuf manages skipping the data is that when we are encoding the data, we are storing what is the size of the data, and also what is the data type of the data. So based on this, and we are also storing the tag number. So we store these three things: tag number, data type, size, and then finally we are storing the data. So it will see that if that tag number does not exist in my schema, then it knows the size and data type. So it will skip that many characters in my stream, and then it will just ignore the field and it will move on to the next field. So that's why these fields were also important to manage the backward and forward compatibility of data. So, yes, okay. Any questions up till here? I think.
The required property or optional property is not part of the data? Or it's only part of the contract?
It's part of the contract. In the contract, you define the schema. So Hitesh, like I can just give you some context. Have you used bond?
Don't remember using it, but
You
I
have
have heard.
not bond. Okay. Okay. Yeah. So people in Microsoft, they use bond, and yeah, and I have seen that.
Is Bond open source? Like, I mean, like, is available publicly or
Yeah.
internal?
Bond is open source. So bond schema is open source. Right? It's open source. So in Microsoft, they generally use bond, and bond, if you will read, it is very similar to Protobuf and Thrift. So Protobuf and Thrift, they are very similar. Protobuf is by Google, Thrift is by Apache, but they have some minor differences, but overall they're encoding this data in very similar way. So yeah, and just like within Microsoft, I have heard that now they're planning to move to Protobuf instead of bond. So anyways, yeah.
Yeah, and one more thing, like I think the Thrift has better backward and forward compatibility compared to the others. That's what I learned. I mean, like read in the book. I don't know if you remember. Mm-hmm.
I don't know about this. Do you have any example of how you can say that?
I don't know, but like I am saying, like I read about, like I have used Avro, but like I think the flexibility it gives you on backward and forward compatibility is more than that of Protobuf and Thrift.
Okay.
So Abhishek, I have one question here. So as you said, the required and optional fields are not in the encoding data, right? That one is not there. But when you do deserialization, at that time when you will be reading, because it is a contract here, so at that time it will fail, right?
It will, yeah. So right, it will fail because it will. So during the deserialization, it will see that. So basically, how it will fail is, so in the schema I have mentioned that the field with tab 1 was required, right? Now it will parse this data and it will look whether a field with tag 1 exists or not. If it does not exist, then it will say that my data does not comply with the schema, so it will throw an error.
Okay.
Right. So while sending the data, you don't need to store this required and optional field. You can infer from the schema and then decide.
Okay. All right. Thanks.
One question regarding the schema, right? Like if we have, let's say, multiple microservices and we are communicating with others. So where does the schema actually, let's say when service A is sending, so I mean, are they referring to a global broker kind of thing to read it, or they all individual maintain their own protofiles to understand it?
Yeah, that's a very good question. So, like in my experience, probably people can share their experience. Also, in my experience, like what we do is, so we define a data model, right? So I have defined a data model class, right? Which is, so for Protobuf, this is my data model. So I will package this, my data model, in some of like NuGet package or whatever open source packaging thing you use. And I will, so whoever my microservice 1, so let's say this service 1 is microservice 1, consumer is microservice 2. So they will use this NuGet package of data model to either write data or to read data.
I see.
And so whenever I will update the schema, I will update the version of my NuGet package. So then the readers and writers should update. Or if they don't update it, then again, it is a matter of backward compatibility and forward compatibility, that one of the consumer, they have not updated the schema. So it is in that backward form, and my now data would be in the new form. So, and that's why I was explaining that why you have to ensure that whenever, so that's why as an author of the data model, you have to make sure that you are not making breaking the backward and forward compatibility of your data. Otherwise, the consumers who might have not updated, you cannot force your consumer to update, right? So if he has not updated the data, it should not break. His existing system should still work. So then if I'm adding an optional field, right? If I'm adding an optional field, which is hobbies, right? And let's say my consumer has not updated the schema. So it will be simple. It will be ignored and it will just read these three things. And for him, the system will work as it was working before, which is great. So nothing else.
Yeah.
So
yeah, that actually makes sense, right? Because like one services, like in the microservices world, it's kind of end-to-end communication. And what is the default value? Like if something is not given, it will be, might be optional or something, right?
Yeah, exactly. Yeah, that's a great question. So yeah, Protobuf automatically take care of giving the default values to the data type that does not exist. So for hobbies, I am not very sure. Either it's null or empty string. So it will give, it will add those default values. So how the default value will be used is, let's say I removed, so my now data was hobbies, and I have written some data in the form of hobbies, and now I wait, how will it happen? Yeah, okay. So I have added this field as hobbies, right? And now the consumer has also updated the package to use the hobbies, but the data which it is reading was written according to the previous schema, which has only this three fields. But the data schema says that there are four fields, hobbies. So what Protobuf will do is, it will read these three values and it will assign a default value to hobbies.
Okay.
I have a question. So when you update this schema, right? How would the consumer know? Is it gonna? I missed that part. Is that gonna send it to each of the consumer, or they're gonna put to the central repository and notify the consumer that there's no new schema there?
Yeah, I don't know what it like. It depends on the scenario, what your use case is. That if you want to if you want to enforce that everyone should update the schema, then probably
I can.
Yeah, if someone wants to answer it.
Yeah, I can talk about not from the ProtocolBuffers perspective, but from the Avro perspective.
Yeah.
So in the Avro world, you have one easiest option. With every message, send your Avro schema. So you don't have to worry about whether you add a field or change a field. Clients will, and all the consumers will always be able to deserialize it. But when we are using the Avro with the Kafka, so Kafka has a separate service, entirely different service. They call it schema registry. So when the producer is want to start, let's say, starts to propagate or what you call publish the message called SD skills, right? So the first thing what he will do is he will go to the producer will go to the schema registry, I mean the developer, and he will say, okay, I am registering a new schema, and the schema registry will give him an ID. ID is just a number. And it will say, okay, SD skills have been registered as ID number 73. And when creating the schema, there are three options. You can say, my schema evolution will be backward compatible, or it will be a forward, or it will be backward forward both. Based on that, you can change the fields or do not change the field. So when we start publishing the messages onto the Kafka, the consumer, what it does is, consumer just gets the meat of the message. Like he doesn't get the schema, but instead of the schema, he gets a schema ID. So with this SD skills message, you will get an schema ID as number 73. Using that number 73, the consumer goes and pulls the schema registry service and gets the schema there and caches it with it. And with this, using that schema registry service, and now since the consumer also has the schema, he can now properly decipher the messages and all. But whenever the the message structure or the schema evolves on the producer side, you have already decided whether you want to do a backward compatible or forward. So at that time, they change the schema and publish the new schema to the schema registry. Schema registry will check whether your schema is voiding a contract or not. If it is not, it accepts that. And next time when the consumer gets the message, he sees that the schema has changed, he gets it again. And that's how they communicate through a third-party service in Kafka.
Yeah, actually, I was thinking about the same way, right? Because when we normally we say backward compatible, like what long backward compatible, right? Like, is it one version? Is it two version? It is 5%? Because if we see right now in a real world applications, APIs are keep on evolving, right? And think about if you are giving a public API and you have like a Stripe API, right? You have hundreds and thousands of customers, and who is using what library, what version. It is very important that you are not breaking the business, right? So at that time, yes, actually I was about to ask that question, that if somebody has to send a version ID, because JSON is currently pretty flexible, and that's the one way why JSON took so popularity, because it's completely unbounded, right? But here, the good part is that the data is shrinking, but there will be additional maintenance, that hey, which version. And the consumers really doesn't have to go to broker every time, because their versions are static, so they can cache the schema, right? So that you can save the every request, you don't have to go to. And then whenever you get a message and your version is not matching, simply you say, okay, hey, this is not what I'm expecting, right?
Yeah. So
one more question.
So just 1 second, John, just 1 second. So just to summarize here, so basically, if you have some external facing endpoint where your schema could be changing, and it's not in your control, this consumer part is not in your control, then probably you will not use Protobuf at all. You will use JSON, because in JSON you don't have to worry about schema. It's schemaless. You can add and remove whatever you want, and it should be okay, right?
Right, yeah.
Right.
Yeah.
So that's what he's saying. But so basically, when you're using Protobuf and all, you have to make sure that it is your internal services. This consumer is in your control. And then, like, basically how we do it is that at NuGet package, you can look at the version of the NuGet package. So this data model, I will create a NuGet package. I will create a version. And then as a consumer, I can look that if there is any updated version of the NuGet package or not. And if something is breaking, then I will have to inform. So there could be scenarios that it is important for me to add a required field. I have to make a breaking change, right? In that case, I would have to inform the consumers that I'm going to make a breaking change. And then you should update your data schema according to that.
Okay, but what again, I don't want to take much time, but even though it is internal, right? Like Google actually started, like if you think about a service within the Google where thousands of products, may not be hundreds of products within the Google itself is using, right? So communicating, to client may not be, because every client will have their, think about a new product which is moving faster, and there is another like a Gmail, or, they all are using. So maybe, I don't know, some kind of, if you're adding a field, just to make sure that, it is only applicable to one version forward, and so that, whomever is consuming that particular version, right, it is not that, like a backward compatibility, what version onwards, right? Okay.
One quick thing, I don't agree that JSON is also completely schemaless, right? Like you change something in the JSON, it could definitely break the consumer.
Actually, that is correct and incorrect, right? As a consumer, normally what we do, I think Abhishek covered that one. When you consume a schema, you have two options, right? Let's say that some of your data does not binding. Then if you are really if you do not ignore, then you are going to fail, because by default, JSON is, it depends on the library. I'm talking from Java library perspective. Like Jackson, or if you use JSON from Google or any libraries, it depends what they are focusing. By default, JSON go with the tight contract. You are correct. But most of the places, because if somebody lets you, somebody added a field, I mean, I'm talking about within internal service, and suddenly that service, because right now the deployments are decoupling, right? Like your service is deploying, at morning 9 o'clock, other services may be at different time. Then normally what we do, we just, like say that, okay, ignore it. Okay. Yes, there may be, because adding a new field on the service as a client, I do not have anything, but as a safe side, normally we say that, okay, anything which is not compatible with the client side parser, ignore it for now. And then we have to see, right? And a lot of places also JSON is started using this kind of concept because of the reusability of the schema. And this is all coming with, like how complex applications are getting. That is.
So one thing here, Naga, is so what will happen is, like, if you don't have that data, then name will be empty, and so your code will still work. But if you're writing your code in such a way that if some field is empty or throwing exception or something, then yeah, obviously it will break. So it depends on your implementation, how you have implemented. But if you want, you can make with JSON, you can make your code backward and forward compatible easily. Yeah, okay, Leon, your question.
There is another model that at least my team follows. It's when it's a pull model, that when you read, instead of push model from application server to the consumers, we follow the pull model. So while pulling, we register with the source or the producer as that we are consuming this particular contract, and the responsibility of conversion, backward compatibility or whatever compatibility is there, it lies with the producer itself to convert that value into a defined, because they are aware of consumer contracts. It's a restricted one where producer want to ensure that only targeted consumers are consuming, and the responsibility lies with the producer only to convert its data in whatever version it is stored, to convert backward or forward to that version that it supports as a and then give it to the consumer.
That's an interesting one. Yeah.
Leon, you had a question. Sorry, you have been interrupted.
Okay, my thing is go back to the basic one, the forward and backward. And, suppose each schema have a ID, a unique ID, then, why we need forward and backward? Because that ID uniquely say, okay, the consumer will only process the order, request coming in with this ID. And because of that ID, it know exactly what schema it expected.
Yeah, right. That's right. But see, imagine that you had these application servers, right? And you were writing the data, output data to some records, right? You're writing to some files. Now, when you are reading, you don't know, right? If you can read the data which was written by the first version or the second version.
But that data, when I write it too, that wouldn't that include the schema that's stored with the schema ID, right? Like D1 with the, the schema ID.
No, you saw the representation of Protobuf, right? We saw, this is exactly how Protobuf is. There is nothing more in it. This is how the Protobuf data is. So there is no field that says version in the Protobuf data. Protobuf data is just the data that you have encoded.
And the same follows for JSON as well.
Yeah, like you don't see any version. Do you see any version number in the JSON data?
But this is the protocol specific, right? But like with JSON, we could have saved the schema ID.
Oh, you are saying I could have added one field which is schema ID. Yeah. We could have added a field which is schema ID. But so what will you do? You will have to write some code, right? That if my application server 1, if it is reading the data which was in schema 2, then, and also, so that's why it is said that backward compatibility is easier to maintain, but forward compatibility is harder, because you cannot change the application service one is whatever your code is already there. You cannot change that code. So now it has to take care that if by default, if by chance it reads the data which is defined by data schema 2, which is the new schema, it knows that it is the newer schema data, but it should not fail and it should be able to interpret that data.
Okay.
Yeah, the schema ID is a hard concept, I believe. What you're saying is like, if a new schema ID comes into the consumer, it will first of all have to download the, if it does not have that schema with itself, it has to download. One question comes by how it will do the dynamic downloading of that and then converting the data. When it converts the data, all the fields are new. How you will address it?
Yeah, and yeah, so basically all that logic is defined in application server 2. Application server can decode the data defined by data schema 2. It has the code to read the data and do whatever it wants. But application server 1 was your old code, right? It does not have that information. So that's why and it's not in your control. You are deploying your service, but it will be eventually deployed to all the machines. So that's why you have to be careful that in data 2, if you have added a new field, which is a required field, and now if application server 2 reads the data, which was a required field and it was not expecting it, then this will start breaking, this will start crashing, which you don't want. At least you want that it should be working how it was working before.
So, sorry.
Abhishek, what you are saying here is basically the schema details would be integrated with each and every instance of the application, is what you're saying?
Yes, right. So this applications, so basically what is happening is, okay, so let me explain it like this. So this applications server 1, right? Let's say built a exe out of this consumer, right? I have built a exe. So that exe has all the information, the schema detail and the code. So that exe is living in application server 1, application this machine and this machine, right? Now I update my code. I update whatever my code is for service 1, and I have a new exe with the new schema that I want to deploy. So first, my deployment pipeline will go like this, that first it will go and update the exes and DLLs of this machine. Then, and also I have no control. I cannot stop my code to run. So this application service 2, once it is deployed, it will start running and it might start producing the data in the new format, which is D2. In the meanwhile, I'm also deploying my service. This exe I have updated here. So in this all duration, what could happen is that this which has the previous version of exe, it could read the data which was defined by D2. And if you have not taken care of forward compatibility in this case, then you might face issues and this system might start breaking and crashing.
But can't we handle these issues using different deployment styles that we discussed in one of our earlier lectures, like a blue-green deployment, where just deploy the service but do not expose it to all the people and just slowly start exposing as we upgrade our infrastructure?
Yeah, but it depends on the scenario. So you are saying that you have deployed yours. I have not attended that class, but you are saying that you will deploy the service only to few machines and you will not expose them to customer. But let's say if you had 100 machines and 20 machines, you have updated the code. So how will you control that whatever data they were outputting, they should stop outputting the data also?
Yeah, old data will be handled by the old deployment. New data will be handled by the new deployment.
Yeah, it depends. So exactly, if
or
it is
same or different, storage will be same or different, the new machine and the old machine.
Yeah. So if your storage is, so if the storage is shared among different machines and if they can access, so there are different models, right? If storage lives in each of the application servers and each application server will read only the data stored by that machine, then yeah, it's fine. You don't have to worry about it. But if the data is shared among the machines and they can, so basically in my team, like what we have is that the data is independent of the compute, right? You can deploy your compute layer to some set of machines and your data would be living in another set of machines. So now here I cannot guarantee that the data which my application service will be reading, it will be reading from the data which it produced. But if your design is like this, that if you have designed it in such a way that you're reading the same data, then yeah, you don't have to worry about it.
So like suppose you have the new schema and that new schema is, delete a require field.
Yeah.
Right. Then when the app server, it get the data and then because it's not compatible. So it always have to go to D1 to get the data. Because if we go to D2 will miss the require field.
Yeah, in case of the question that you're asking, in case of a breaking change, where application server knows if it introduced the new schema, it is going to break the consumers. So at least I can say from my team perspective, the way it is handled in our scenario is we have two environments, the production environment and int environment. And we enforce consumers to tie or to start deploying these are the new changes where the required field will come. And you have to enforce those changes when that kind of data will come. So it's this behavior is something where you know that if you introduce the new data with the new field, it's going to break its consumer. So you have to coordinate your effort or deploy your new changes such that it does not break them.
But Hitesh, is that really possible in the, like whenever we have a lot of consumers, like, I'm talking about a practical production perspective, because every team will have their own, like, isn't something we need to be think about backward compatibility? And I'm not sure, it depends on
people do
service
think
to
about
service.
Okay. People do think about backward compatibility. I'm totally in, but sometimes there are breaking changes which introduce that this property does not make any sense, which was a required property earlier on. Suppose it can be
okay, I see.
It was a required property earlier on, and now this property does not make any sense at all.
Yeah, so just need to bring all those. Okay.
Yeah, and there can be like, the customer is purchasing something, and our tax or our government mandate that this new information regarding the customer should also be there, or a new information regarding the product must be there, and this information has to flow to the consumers. So how will you guarantee? So sometimes there are breaking changes. Most of the time there are no. People keep on, like in this example, like at least from my team perspective, but I'm saying the consumer don't worry about the contract changes. There is a layer between when you read the data, when a consumer read the data from storage and take it, there is a line in between, or there is a box in between, which does the translation for them, which keep registered, like these are the consumers, these are the contract they are reading from, whatever is there in the storage, transform them into consumer readable contract and then give it to them. And that component is owned by the producer itself. Now there are, like I said, there are changes sometimes which are breaking changes and you can't do away from them. Then it has to be a coordinated effort, because the producer, in the scenario that I'm trying to tell, is producer knows about its consumers. And I think in this particular scenario where consumers are not known to producer because probably they are directly reading from the storage and the producer doesn't know. So in this scenario, probably, it's very hard to enforce or introduce a breaking change, and they should not.
Correct. Yeah, makes sense.
Or maybe introduce a new storage, which is a new schema. People will stop, maybe the consumer will not see any data here. A notification to them, start reading from a new storage, and this is the new schema. Maybe there are a lot of ways to achieve that goal.
So can you a little bit emphasize on what is the coordinated effort? How will we actually do the breaking change? How will we deploy the breaking change? Do we stop? Yeah.
Actually, it is also possible in case of, like somebody was explaining a Google scenario or so. It is always possible that things are evolving. A new change might get introduced where a new property is there, which is a required property, and or maybe an infrastructure level change also, like, you are reading from D1 and D2, which is kind of some database which will go out of existence. And you have to introduce a separate database, a separate URL or something, or it has gone to a different data center or something where consumer there's no data being produced out there. It's a separate place. You can notify them. Then this storage is being decommissioned. A new storage is being lit up, and then it's almost equivalent to stopping the consumer from getting the data. And then if they want to read the fresh data, they have to move to the new source.
Yeah. Okay. So you need some downtime probably to.
It is not necessarily a downtime for them. You can definitely tell them in advance, start reading from this particular source. We will start pushing some test data out there. Like, the data can have a test column. It's a test data. You can test your integration. You can test that you are also able to read data from there. As soon as it will lit up, the application server will start producing the data. You can definitely, instead of simply pushing the data, the coordinated effort says that we will start pushing the data from so and so date, get ready to consume it. If you don't get ready, either you will not see a data, or it might be a breaking change, and that can cause trouble. It has to be a coordinated effort whenever you do a breaking change or an information. If it breaks, then it's their responsibility. Probably they're no more using it, even if they're reading it. And it's also possible, like, the green box that you are saying, there can be n number of the consumers which you don't control. They are not in your environment. You are simply producing your data in some storage in the cloud, which is consumed by anybody, open for anybody to read. It's very hard to, coordinate that effort out there.
Or I think we can also keep our older version of the services as well, and take care of those things at the API gateway level. Because when we mentioned about in some sessions, I think API gateway can do multiple things, right?
Yeah, I mean, as long if you keep on doing so, it also people keep on doing. I totally understand where you're coming from. To put data, it definitely needs some engineering efforts, right? How many versions or how many backward compatible version will you keep on supporting? Right? At what point you can call it, like, I give a simple example of, let's say, Microsoft Windows, like, that we have Windows starting 2006 to people will take a dependency. Most of consumer don't even care about upgrading their sources, upgrading their product or so. Why they should do, unless they care about the new feature or something, right? But till what point in time you will decide that I'm not supporting this anymore? So those things happen, like, like Orkut from Google, that product, they have to deprecate it. Now, even if there might be a consumer consuming from it, what they do, they notified, right? To the people that, we are going to decommission this product that we have been offering, because there is an engineering cost involved with supporting so many things, the backward compatibility and forward compatibility. At certain point in time, you decide to stop it or move to the new one.
Yeah, that happens all the time, right? Like every year Google is deprecating a lot of products, like almost 5-6 products, and they'll say, okay, you just need to download your data, or if there is a replaceable place, then you can just, I mean, that is completely, that has to happen. Otherwise clients will never upgrade, right?
Yeah, there are some clients which will never upgrade because they don't care about the feature. Sometimes they don't care about the feature. And it's also possible today it's a Gmail account, maybe some later on it becomes Google.mail account, and the responsibility they put on the consumers to migrate their content and have at least press a submit button that it will migrate their content. They might not do it, and you will stop getting the emails or so. Even if they are the sender is still okay to send both on Gmail or Google Mail or something. So there are across the world there are in all possible scenarios there are breaking changes that happen. They most of the time there are so many consumers you don't know. You probably notify them and give a particular date that we will stop subscribing to, or we will stop producing the data, or in whatever way. I mean, there are various scenarios where everybody has seen at least these things in production, or in personal life, or in or across browsing or different websites. They keep on coming and keep on going. So there are things that happen.
how is it data encoding, decoding related to, is that like similar to how REST API is?
What, how is it similar to, I didn't get your question.
Is that similar to how REST API, you know,
No,
it
I mean
also...
REST is, network
yeah, it's a
communication.
protocol, right? Like it's on top of HTTP, so it has all that semantics. And basically, even if you use REST, when you are communicating over the network, you end up using JSON, which is again another kind of encoding. So text encoding.
Yeah, in case of REST API, you generally perform two kind of operation. Either you get the data or you post the data. And encoding is mostly about that data, which either you are sending in terms of a post call or you're trying to get in the terms of response. How that data comes over the wire, because it's nothing but it's a stream of bits or stream of bytes. And what that stream of byte represent is the encoded form of some content, which can be JSON, it can be CSV, it can be a simple string, it can be anything.
But REST API also have a version. Is that like take care of backward and forward compatibility?
No, there you have to.
That is not compatible.
Yeah. If you are using one URI to represent one API, so if you have to change the version, you typically end up changing the URI of the another version. I mean, like if you have to keep two versions in REST, probably easiest way is to have two URLs to represent two different APIs. With
that is correct.
like a V2 or something. Yeah.
V1, V2,
yeah. And PayPal is also, Braintree, they are maintaining, because some of the clients, when, initially they send out the versioning in the header, but then the latter, right? The majority of the consensus is that, some of the clients still they're following, but you cannot identify the version, right? If you go to Braintree and lot of, public APIs, they will explicitly mention. So at that time, right, as a consumer, let's say that if I'm using version 40, then the producer is supporting, maybe producer is at version 45. Okay. So they will clearly say that we are going to support at the, 1, 2, 3 version. So if you are not upgrading, let's say producer is at 4th, you have to come to 2. Those will be part of the contract. And whenever you read the URL, okay, you are expecting as a producer that, hey, if somebody is coming with V2, then they are sending the data in the V2 format, right? So yeah, in that case, the REST API is, how it is serving very well to the public APIs compared to the Protobuf, right? Which is internal, it can compress a lot of data communication.
This encoding normally, like mostly, I think the JSON is most used even now. But like this encoding, like Protobuf, Thrift, or like whatever, or every company has, like Avro, these are all normally used, like mainly if you look at the scale in distributed systems. So if your number of messages is quite less, or you are not worried about the size, then you might as well end up using JSON, so which is human readable, which is good. But like the size and the performance matters. I mean, like, and if you have like if you look at the Facebook or any top companies, they have billions of messages coming or millions of requests per second. So there, even if they reduce some small size over the network, little bit, like half, this will, most of them reduce at least by 50% or even more. So, which is quite a significant network improvement, right? So, sending 1 MB data and 500 KB data over the network, you obviously know like 500 KB can reach much faster.
Yeah.
So,
but Naga, even
and
if
also encrypted form can be there, right? Along with the Protobuf, maybe before Protobuf, you can encrypt the data and send it over the web. Encryption also has a significant reduction on the size, maybe 10% to 20% or so. It can become from a regular JSON to just 10% of it.
I just wanted to differentiate like encryption from encoding. So Yeah, encoding is basically is about all this reducing the size. Encryption is for security, right? So you don't want others to eavesdrop.
So yeah, so no, so basically encoding is here. So Hitesh, encoding is that you can send the data in the form of bytes, and also like a part of encoding is you are compressing the data, but you are not ensuring that if someone intercepts your data, he can read the data. Like we saw in JSON, Protobuf and all, if someone interprets your data, they can read the data. But in encryption, you are making sure that when you're sending the data across wire, if it is intercepted by someone, they cannot make sense of the data. So
correct. I think encoding, undoubtedly, encoding is needed because the data that is stored behind the scene on the hard disk or it goes over network, it goes into encoding format, whether it goes into the NSI form or any form. Now, as far as storage is concerned, in general, at least my team, we store the data in an encrypted way, not just for security purpose, but also for the size perspective. The R environment is a closed environment which does not have any consumer outside. It's only restricted set of consumers can be there, which are registered with the producer that these are the consumers. So all those things from that perspective are handled. And its compression is also used to just not just for a security purpose, but it is also for less storage.
Yeah, so I'm just guessing that it would be the feature of those encryption algorithms that they are also encrypting your data and also they are reducing the size of the data. So they are doing two things at once.
Yeah, sorry, I think I said the wrong word here. I just meant the compression actually.
Yeah.
Okay, so they are not encrypting the data then.
Not necessarily, but I wanted to say compression, but it just came out of my mouth as an encryption.
Okay,
yeah, I think encryption, like unless or until you are dealing with some PCI or PII or any personal information, right? So yeah, I mean, in my project, like we are dealing with a lot of payments data. So even though I can give you the JSON string, but the account numbers will be AES-256 encrypted, right? Like which is very different. Like you cannot understand anything, but other fields you can read, like non-PCI or PI data. And that is actually over the wire, right? You encrypted the data. Now you are going to the endpoint, right? You need to store. So there is something encryption at store, right? Because both are two different things. You do not have to store encryption in AES-256 or any MD5 or something. Those are over the wire encryption, right? But the storage encryption is different. And right now also, even though Mac OS and Windows OS, even somebody is taking your hard drive, they cannot really decrypt it. And then third thing is the
But if you encrypt the data, in certain format and you store it, and later you want to change different encryption algorithm, then it could be overhead, right? Instead of you store raw data there and you encrypt it on the fly.
Yeah, let's actually keep the encryption questions to some other session, because whenever somebody is covering security. So, I mean, like to answer your question, like if you are encrypting or some encryption algorithm, so you have to decrypt to a plain text before you use another algorithm to decrypt. So, to encrypt, sorry.
Yeah.
So
SSL does that, right? For us, we don't
yes,
have to worry about it.
Yeah. So if you use HTTPS, you don't worry all these things because it's been taken care internally. So
And another term is hashing. Could you explain
hashing is not encryption. It is just like it's meant for different purpose, but like most encryption algorithms use hashing to do some other things. So which we can actually cover in other topics.
Yeah, hashing is basically like you are making the access for that particular data easier. It's like the way I know it is in the terms of search. If you're looking for some data to search, you don't have to search the entire data. It is hashed, and then you can go to that location and find the data. So I don't know how it is being used, like in the networks and in communication. I don't see a point
I
of
can
hashing.
actually. So yeah, maybe in the interest of security, like one-way hashing is used is like if you have a some file, like if sender is sending something, and there are two concepts like when it comes to security. You have to verify the authenticity. It's coming from the right source, right person you wanted, and it's coming as unaltered. So the message is same as what the sender sent.
Yeah,
So,
one example of hashing, I mean, I can think of is like when you store a password, you know, when you change your password, the way it is stored behind the scene in the database or in somewhere, it is actually a hashed value, something, some value of, you know, your, it's some function of your password, which yields some results, which cannot be taken back to the password. So it's a one-way mode only. So when the data is stored behind the scene, it's a some form of your password. It cannot be taken back. There's no way that you can, you know, derive that function cannot be backward way. You cannot get your password back. So when somebody try to authenticate themselves, their password goes through the same function, and then compare the content with what is stored in the database. That's how things are. Maybe either your face algorithm or your
let's keep
Okay.
the hashing and security to another session, because I have the topic mentioned in one of the system design topics.
So,
one quick thing on
Any final questions on this encoding?
Just one final thing. Do we want to go to Avro? I think we have only 5 minutes left. I don't know.
No. I don't want to at this point. So let's take Avro, and like if somebody wants to do an example on Avro, Abhishek, do you want to do, or like
I have not actually used Avro, so I think it would be better if someone has used it.
Yeah. So I think Drupad, you are the one who you are presenting the Kafka scenario, right? Do you want to present in one of the sessions?
I've just started. I do not have a deep understanding of it, so I'm really sorry about that.
Yeah, no problem. Like, okay, let's if Abhishek, for today probably let's call it because we just have only 4 minutes. We cannot finish that. Let's probably cover in one of the coming weeks.
Yeah.
Maybe we can add some other topic along with that and cover.
Okay.
Thank you, Abhishek. It was amazing.
Yeah, this is a great session, Abhishek. Thank you.
You had it like along with the practicals, and it was a wonderful session, Abhishek.
Thank you.
Let me pause the recording, stop the recording, and we can continue to.
Thank you. One quick question on